This is it guys, our first gaming tutorials on the channel. Great, isn't it? We'll start with some systems that I found relevant when you are beginning your journey in Unreal Engine 5 on a gaming perspective. I'm going to explain two types of triggers using a simple lighting system. One switch trigger using inputs and a detection one. Let's go. Welcome to Prosport Crash Test gaming scene. Colorful and ready for a lot of various tutorials. As you can see here, I've prepared two areas where I will display the two lighting blueprint system. Let's start with the switch trigger using inputs that we will determine directly in the blueprint's event graph. First, of course, you'll need to create a blueprint actor. Go to your content browser, right-click, select the blueprint class, and go for the first choice here, actor. Let's give it a name like BP_trigger_input_lighting. Open it to begin building our code logic there. First, I'm going to give you a visual look of the blueprint actor itself, and this is why we have the viewport tab here. For this tutorial, I'm using assets of this free pack called Hollywood Movies Props Volume 3 that you can find in the permanently free collection of the marketplace. I'll give you the link in the description. Let's add two static meshes components here. You can first select the static meshes you want in the content browser and then add the SM components directly with the active selection. That's a time saver. Let's adjust the position of our meshes here. Then let's add a spotlight, which is going to be our main actor. It's kind of tricky to know exactly how we are building our blueprints in this mode. This is why I would recommend placing it in your scene and adjust everything with both windows. Right away, you can see that I like some details and power on my light intensity. So, in our blueprints, I will first set the intensity unit to candleas in order to retrieve basic values that we have when we use light actors directly in the scene. Then, I'm just adding an IES texture profile here, the complex_IES1. If you can't see profiles here, you may need to enable the show engine contents via the little gear icon here. Finally, I'm adjusting the intensity to a value of 20, an inner cone angle to 30, and the outer cone angle to 31, just to get a sharper fade-off. Let's look at our blueprints in-game. As you can see, it's missing something. It's not realistic enough because we don't have any source emission from the mesh itself here. Thanks to this free pack, we have a quick solution here. Indeed, the material instance is already all set up. I just have to open the material instance itself and enable the emissive feature. Last thing that we could arrange is the volumetric spectrum of our spotlight. We can create a specific material to affect this, and this is probably the more optimized solution. But for the demo, I'm just going to enable the volumetric option on the exponential height fog of my scene and increase a little bit the volumetric scattering intensity of my spotlights back in the blueprint. There, all good now. Now, what we want to achieve is the ability to switch on and off our lights via one input. To do so, first we will need an important component, which is the collision component. Let's pick the sphere shape one. These components will help you determine a specific area that you will use to trigger events. As soon as my character will enter this zone, I will give him the ability to use a specific input to switch on or off the light. Simple, right? So let's just adjust the size and placement of our sphere collision here. Oh, and don't forget to rename these components if you want to easily retrieve it in your graph afterwards. Let's go down to business and go to our event graph. We won't use any of the default events presented here, so you can erase all of them. Select the sphere_collision. We will use two on-components events, the begin overlap and the end overlap one. Go on the right-hand side and scroll down in the details panel. Below events, click on the plus icon of both on-component begin overlap and on-component end overlap. You might reselect the components after clicking on the first one. This is where we are going to define the area where we'll give the ability to our character to use a specific input. We will set up the input right after. First, let's build the area logic here. As I said, we are making something concerning our character, which is here the default BP_third-person character. We are building the who of this event. To get that, I will cast to my character. Just press tab and look for cast to BP_third-person character. Connect the execution pin and the actor reference as I do here. We set up the how, which is the overlap event here. We just made the who logic, then we are going to set up the what part. What is going to happen? We just want to give the ability to use a specific input in this zone. So we just use here the enable input node directly. By doing so, if our character will be outside the sphere collision area, he won't be able to use the inputs and to switch on or off the light. Bring the node and connect the execution pin here. We already have specified the actor reference, and as it is using self tag, we won't need to connect anything else. Last thing to consider is to specify the player controller. So just click and drag the player controller input here and look for get player controller. Great, almost there. Now we have to specify the end overlap event. This is going to be really simple, as we could just duplicate all the parts we built here except for the enable inputs. But to make it clearer, first let's duplicate the cast2 bp_third person character node. Connect everything here, same as we did recently. Now instead of enable, we will disable inputs. So just look for disable input node. And there, let's just connect the same get player controller node to the player controller here. Awesome! Now, we'll need to tell Unreal which input we are going to use in this area in order to control our lights. I'm just going to use the E key on my keyboard here. We can make the system in various ways, but here I'm going to use the flip-flop node directly. When I press E key, the A pin will execute first. Then I will press E again, B pin will execute, and we'll go back to A, and etc, etc. So when I press E, first I want, for example, to deactivate my spotlight. To do so, I can play with the intensity of my light directly, for example. So let's look at the set intensity node with the spotlight component as target. This is when I will press E to switch off the light. Let's define the B way. Really simple, just duplicate the set intensity node and adjust the intensity float value with the same value we put in the first place in the viewports, which is here 20. Don't forget to specify here the target again. I'm just double clicking on the wire here to add some reroute node and better organize my drive. So let's try this out now. As you can see, I'm able to switch on and off my lights using the E key. When I'm leaving the sphere collision area, even if I hit E key, nothing will happen. Our code is correct and our system is on point. But we are not done yet, right? Because if you turn around a bit the camera, as you can see, my emissive part of the mesh is not following the logic here. Don't worry, I have a solution. Back to our graph, we will continue the code right after the set intensity nodes. And here we will try to retrieve the parameter name that is currently driving the emissive part of the mesh. If we look into the Mario instance, I should be able to retrieve this letter. Here, emissive color multi. I play between a white value, as it is here, and a black value to switch it off. Drag and look for set vector parameter value on materials, with the correct target, the SM stage lights 0 and T here. Specify here the exact correct name of the parameter you want to play with. To ease the process, just copy from the master material the name and paste it directly in the tag area here. I will leave the parameter value to 0, 0 here, as it is the switch off moment. We are using a 3-vector constant node here, so we can use XYZ for RGB. Duplicate the node to make the off part. And for these parts, I will just add a value of 1 on each to give a white value. Don't forget to specify again the target here. Let's run the game and see what is going on now. And our system is working perfectly. To finish the tutorial, I just wanted to show you a detection zone example, meaning that you can simplify the system we built here and trigger the switch on and off events of our spotlight without the need of any inputs. Just duplicate the blueprints we made in the content browser and let's rename it bp_trigger detection _light and place it in the scene. Let's open its event graph. We'll now place all the set intensity on and off parts right after the on component begin and end overlap event. After erasing the upper part here, just reconnect everything as I do here. So now we just have to enter the sphere collision area to trigger the light events without using inputs. And voila! I hope this first gaming tutorial helped you understand all this triggered system. Let me know in the comment how you manage all that. Thanks for your support, don't hesitate to leave a comment, like and subscribe to our channel. I really appreciate the support. Bye!